Now let's shift to the compounding interest calculations. Let's shift to the blue color in order to be differentiated. Yeah, now it's clear. Compounding interest calculation. The concept of the compounding interest calculation is more complex than the simple, but it is more realistic and more used in the practice. The compounding interest calculation concept is based on the interest at any year is based on the ending balance of the previous year. Let's understand it by taking an example. Assume that you are going to deposit $100 again at your bank. So we are going to deposit it in our bank for 2 years, for example. This is year number 1 and this is year number 2. And this is the initial deposit amount that we referred to by P here in this example. This is B, the principal. Okay, so we agreed with the bank that we are going to leave the money at the bank for 2 years, and the bank is going to give us 10% R, which is R, the interest rate on our investment or on our deposit. So now let's answer the same 2 questions again. Question number 1, how much interest we are going to earn on each year? And the question number 2 is how much our ending balance at end of each year. Let's start by the first year. The interest of the first year will be based on the deposited amount or the initial deposit amount, because this is the first year. So you are going to say I deposited $100 in the bank and I left it for 1 year, so I am going to take the interest of 10% on this amount. So the interest in this case will be $10 on the first year. Okay, how about the ending balance? This is the first year and I only earned interest on 1 year so far. So the ending balance will be the interest that you have just calculated, which is $10 plus the initial deposit amount that you deposit at your bank, which is $100. So at the end of the first year, you will reach to ending balance $110. This is exactly the same ending balance of your investment at end of the first year under the simple interest calculations. It is the same calculations under simple and compounding interest calculations, because actually we are in the first year. Take care that our assumption is interest is based on annual basis. Interest is calculated on annual basis. But if the interest is going to be calculated on a monthly basis or on a weekly basis or on a daily basis, the calculations will be different. But because actually we are explaining something now, it is basic understanding for the simple interest calculations and the compounding interest calculations, I'm assuming for simplicity that the interest is calculated on an annual basis. Now let's go for the second year here and calculate the interest. The interest for the second year will be based on the ending balance of the previous year. The previous year here, which is year number 1, how much is the ending balance? It's $110. $110 will be the base of your calculation to calculate your interest. So it will be $110. This is my ending balance of the first year, or the previous year I mean, times the interest, which is our 10%. So it will equal $11. This is my interest for the second year. How much is the ending balance for the second year? The ending balance for the second year again will equal the ending balance of the previous year, which is 110, plus the interest that I have just calculated here for the second year, which is 11. So the result will be $121. This is the investment this is the ending balance of my investment, of my deposit at end of the second year. Now let's compare between the investment at the end of the second year under compounding interest calculations and under the simple interest calculations. For the compounding interest calculations, it is $121, and for the simple interest calculations, it is $120. Yeah, the difference is only $1, but don't think that it is very minor difference between simple and compounding. I'm assuming $100 deposited at your bank, but if you are talking about $1 million invested at your bank and in a deposit, So the difference will be huge between the simple interest calculation and the compounding interest calculations. And one more assumption, I'm assuming in my example that interest is calculated or is based on annual basis. But again, if you are doing the calculations on a daily basis or weekly basis or monthly basis, the difference and will be huge between the simple and the compounding interest calculations. Now let's return back again to our example here. This 121, it's all about what? It is about the initial deposited amount plus interest of the first year, and both of them will be used as a basis for the interest calculation in the second year. So 121, it's based on $110. This is the ending of the first year. This is the ending balance of my first year. So it was $110 plus the interest of this $110 multiplied by 10%. So this is the interest of the second year, and this is the ending balance of the previous years. Both of them, if you're adding both of them, it will result in 121. Now let's understand it in terms of a formula. This 110 equal what? Equal P, which is $100 that I deposit in the bank, times 1 plus R. R here is 10%. Then you take it again to explain the 110. You take it again, P, which is $100, times 1 plus R, which is 10% in our case. All of this multiply again by 10%, which is R at our case. The result, so this is the R that I'm referring to. The result of all of this, that if you'd like to calculate the 121, it is all about how much amount I deposited in the bank at the beginning of the first year times 1 plus R. R in our case is 10% to the power of n. This is the conclusion of the above formula, to the power of n. This 121, because you are going to receive in the future after 2 years, as long as you are going to receive it in the future, it will be called future value. It will be called future value. So the future value equal how much principal you deposited in the bank at the beginning of your investment times 1 plus R. R, this is the interest rate that I'm referring to, or the bank is giving me, to the power of n. This refers to the number of years. N refers to the number of years. And in this case, n, in this case, because I'm talking about 2 years, it will be 2 to the power of 2. If you solve this one, it will be equal to 121. Again, let's take the example of 10 years. Let's assume that we need to calculate the ending balance of 10 years. So we are going to assume n to be 10 years. So how much is our future value? How much is our future value? So I'm saying that future value equal how much principal? It is $100 times 1 plus R. R here, this is the 10% that I'm referring to the power of n. N refers to the number of years. If you calculated this one, it will equal 259.37. This is the ending balance after 10 years. Now let's compare between this one and the ending value after 10 years under the simple interest calculations. It is 200. Look on the difference. After 10 years under the simple interest calculations, you are going to receive $200 from the bank. But under the compounding interest calculations, you are going to receive from your bank 259 after 10 years. Again, the difference is big difference. And if you are talking about hundreds of thousands of dollars or millions, the difference will be huge. You cannot imagine the difference. The difference will be huge. Now, let's summarize our discussion in terms of finance formula. We calculated the future value. This is the amount that I'm expecting to receive in the future. This is equal how much amount you received, you deposit today in the bank, which is the P itself, times 1 plus R. R refers to the interest rate to the power of n, and n refers to any number of years. And if you know the future value, and if you know the R, if you know n, but you need to calculate b, for example. So p here equal future value divided by 1 plus r to the power of n. So it is a very basic understanding of math. You are getting p on the left side, and P equal future value divided by 1 plus R to the power of N. So for example, if you are going to receive 259 in after 10 years, and you know the R, which is 10%, and you know N, which is 10 years, so you need to calculate B. B here will be $100. B here will be $100. How can we use it? Let's understand it from a different way. If you would like to receive some amount in the future, but you know the amount that you need to receive in the future, 259, and you know the interest rate that the bank agreed to give it to you, which is 10%, and you know that you are going to keep it in the future for 10 years, for example. So you need to calculate how much amount should I deposit today in the bank in order to receive in the future a specific amount that I need, maybe to pay an installment, maybe to purchase a building, for example, maybe to do anything in the future. So for this amount, which is the future value 259, it is known for you. But you need to calculate in another different way, that you need to calculate the principal that I need to deposit today in the bank in order to receive 259 in the future. So actually the principal equal the future value divided by 1 plus R to the power of N. One more thing before I finish this video. The B, which is the principal that I calculated today as $100, this is called also present value, because actually the value of the money today, the value of $1 today equal to $1. Okay, so now we need to understand that whatever you deposit in the bank today, it's called the principal, and it is based on the value of the money as of today, so it's called the present value in the same time. So the present value today, I deposited how much? $100. The $100 I deposit today, by the value of today, it is $100. That's why it's called the present value.